In this video, let's discuss sets. Sets are also a data structure that helps us to keep items. For example, we may have a set that looks like this. So I'm going to create a set that contains a list of, that contains a collection of numbers 1, 2, and 3. Now, the difference between a set and a list is that a set contains distinct elements. For example, we can only have one existing as one in the set. Now let's show you how that works. So if I add 1 and then 2 and then 3 and then let's say 45 and then other values such as 56, when we print our set and we run our file, so I'm going to open up my terminal and run this. So I'm going to say python sets.py. So you're going to see that none of the items is being repeated, even when we have them as repeated. So we always define a set as a collection of distinct items. So as you see, we can only have an item existing as it alone within our set. Now let's also check out how to create a set. Now, if you're to be keen, you realize that our set has brackets similar to those of dictionaries. So when creating a set, we do not use that. So when creating an empty set, we don't do this. So when you say my set, we cannot do this. This does not work. This is actually creating a dictionary. So this is creating a dictionary. It's not creating a set. So when creating a set, what we do is to say, let's create another set. And in this case, I'll have to comment this line. So after commenting that line, I'm going to create a new set. So let me create a name set. So I'm going to call this name set, and this is going to be set. So this is how we create a new set, a new empty set. So when you try to print the name set, so I'm going to run this, and when I come to the terminal, I run with python sets.py. We are going to create a set, and this is going to be an empty set. So let's try to add some elements to our set. So to add elements to our set, we are going to say name set dot add, and then we assign the element we would like to add. So let's add Jonathan. So let's also do the same. We're going to add other names. So I'm going to say name set dot add. So I'm going to add Moses, and we can also say name set, and then we add going to add Jerry, and let me add name set dot add Alan. So when I save this and print our set, so I'm going to print name set again after adding items. This is going to be the name set. So when I go to the terminal, we shall see that a set is going to be created. So when we add items, it is going to be a set containing our items Jerry, Alan, Jonathan, and Moses. So let's try to access the items within this set. So to do that, we're going to print name set, and then we print the item at index 0. So I'm also going to print name set index 2. So let's save this. So when I come to our terminal, we first clear this and run sets.py. So we see that it's going to give us an error that we cannot be able to access elements in a set like the way we do for lists. So let's see how we can be able to remove elements within our list. So we have elements within our set. So we have our set having 4 names. Now let's try to remove a set. So to remove a name from the set, we are going to say name set dot remove, and when you try to remove items within our set, we are going to specify the item we may want to remove. So in this case, I'm going to say Jonathan. And then you try to print our name set again. So let me open our terminal. So we see that our set has the name Jonathan removed. So when you create a set, we create it by creating a new set instance. And after creating the instance, if you're confused by the word instance, we shall cover that later when we come to object-oriented programming. So we create a new set object, and when you create that new set object, we call this add methods to be able to add elements to that set. Now when you want to remove, we also call the remove method, and we specify the element we would like to remove from our set. Let's try to see different operations that can occur in sets. Now, if you have noticed, sets are the sets we usually discuss in mathematics. So these sets can have various operations. So let me try to write down these operations. So we have operations on sets. So we have the intersection. We have the union, and we have the symmetrical. We have intersection, we have union, we also have the symmetrical difference. So I'm going to comment this. So let's try to see this in action. So I'm going to create two sets that have values. So let's try to create two sets. So I'm going to create a set A, which is going to have values 1, 2, 3, 4, 5, 6, let's say 78. So and set B that has items, let's say 2, 4, 6, 8, let's say 10. So let's first try to print the intersection. So let's call this intersection. So we are going to print an f string, and this f string is going to be showing us the intersection. So let's say a intersection b, then we're going to write the intersection. So we're going to do this by saying a dot. So we see that the different methods that we can run on sets. So we can say intersection update, is disjoint a subset, to find out whether it's a subset. We can do quite a lot of interesting things. So let's try to do the intersection. We need to do the intersection and then call this and pass the other set that we want to find out whether they have an intersection. We're going to do this the same thing for the union. So I'm going to say union, and I'm going to print f, and I'm going to write a union b, and then this is going to be a dot. So this is going to be a dot union b. So let's try to find out the symmetrical difference. So I'm going to say a symmetrical difference, and we're going to do the same thing. So I'm going to print f, and then in this case I'm going to say a. So a and a so this is going to be symmetrical difference, is going to be those elements that only exist within both sets but are not shared among all of them. So we're going to say a, actually this is going to be, let's try to just print it out. So I'm going to say a dot symmetrical difference b. So let's try to see this. So if I run my my file within our terminal. Let me first comment out these other print statements. I'm going to comment this out. So let me save, and when I come, I'm going to run our Python file. So this is going to print our, so we have A intersection B. So let's check this. So when you come this side down, we are having assets that have 2 and 2 existing, 4 and 4 existing, 6 and 6 existing. So we have our, let's, so we have our A intersection B as 2, 4, 6 and 8, and we have our A and A union B as 1, 2, 3, 4. So that's like elements that are existing within both sets, within all their sets. And we have our symmetrical differences, those numbers that do not exist in the intersection. That means they only exist within A and B but are not shared. And we have 1, 3, 5, 8, 10, and 78.